Good evening, friends. Welcome to Eason Academy. We are discussing about controller programming as a part of embedded system programming. Today is a session 3, and in this session, we're going to discuss about LCD controllers. That's the most used one in the embedded industry. It's because of its power. So let us as usual, get into the board and try to discuss about LCD controllers. So what is the basic difference between LED and LCD? It's very simple. It's like a sun, star, or moon, satellite. So the star has its own power, light source. The satellite only reflects the light. So if there is no light source, then satellite will look like a dark. Whereas star, it's always bright, gives a light. So if the source of light is star, the satellite is the one which reflects the light. The same way, the LED, which emits the light. You will know that cathode, anode. It emits a light. So if you give a power, it emits a light. Whereas this is LED, own source of power, light. Whereas LCD does not do that. Yet, if the light comes here, it goes back and comes back. It reflects and comes back. So if you block the light from going to the other side, then you will see a black spot because there is no reflection at all. What people do here is this liquid crystal. That's what they use here. Liquid by applying the voltage, they make them either block or allow the light. They polarize, non-polarize. That's all physics. I'm not coming to the thing. So both are same, but one problem is when a room is dark, LED will give light. But when the room is dark, LCD will not work. That's why all the LCDs has something called backlight. What they have it? Backlight. Today we are seeing the TV. Everywhere people are advertising that. They are advertising LED TV. Everywhere they are advertising. We have a superb LED TV. But let me be honest. There is no LED TV in the market. There is no LED TV in the market. Okay. All the TVs are only the market, whatever you are buying, they are all LCD TV. Not LED TV. Actually, it's like this. What they have done was, the LED will be, if each dot is a LED, then it will consume huge power. It's not possible for you to have that. And it will produce huge heat also. So the LCD, what happened? Every dot, this is what you call it as a pixel. Okay. That's all you call resolution. You say your monitor is 1024 by 768. That means you have 1024 dots by 768 dots. Now, the trick is this. What is the backlight? Initially they use general lights, then CFL. Then they start using LED as a backlight. Understand? Backlight. Your mobile phones, you increase the brightness or reduce the brightness, you are increasing the LED backlight power. That's why when you have a more brightness, then the battery get discharged faster because of this LED backlight. Now the trick is, actually the LED TV is called LED backlight LCD TV. Am I right? This is what the actual name of that LED backlight LCD TV. That marketing people have removed these two automatically. So it's marketing. They are marketing you as a LED TV. There's nothing called LED TV in the market. So please understand, every LCD display have the backlight. Normally, if you stick to your TV, somewhere if you don't have the color properly, there's a blur color or one line of thing is not coming. That means that if you open the LCD LED TV, the back, there'll be strips. There'll be strip of this one, LED strips. And everywhere there'll be LEDs. If you open a TV, you'll see a lot of strips in the back. So that's all backlight. That's actually, if you don't have a light, the back, see, this is a display. If you go into the dark room, if there is no light, so what is happening, if I make the LCD as a polarized, since there's no light reflects. So you don't see the display will not be visible. If there is no light in the back of the display, the back means it's like this. Actually, it's called back of display light. It's actually on the back of the display. Every display, the back side, there is a light. So you see a TV screen. On the screen is top. On the back, there'll be a light. This light is the one which is giving you the brightness. By controlling the light brightness, you can see the TV more bright or less bright. In the LCD display, more bright or less bright. This is all controlled by your backlight. So that's why they call back. See, it's all back of display light. They remove this. They start calling it a backlight. This is all industry conventions, and you need to understand. So what you are doing in the LCD display is you make the liquid crystal to block or allow. If you block, that dot is dark. If you allow, then the dot is visible to you. That is what you are making on the LCD display. Please understand what is LCD display. So we are not going here. What we are going to do here is, for us, there is no difference between LED and LCD. No difference. In this case, you give voltage, the light is visible. It gives the power. Here also, if you give voltage, this is visible. That's all. Don't get into too much of this one. So every dot. Now we discussed on the LED is single LED. Then we discussed. Then we discussed about simple 7 segment. Only one segment. Then we discussed about dual segment. Then octal. The problem with the 7 segment is you can display 0, 1, 2, 3, like that only. You cannot display any other characters. That is the reason we have discussed about dot matrix. We discussed about dot matrix. So there's so many dot matrix. That is, we have the 8 by 8 row. Or they have so many methodology. They have a 7 by 5. They have different sizes. Now, in this dot matrix, you can display A, B. Every character can be displayed. Okay, let us. I'll show you a data sheet. Then you'll be know that how it is visible to you. One minute, we share it. So then you'll be able to see that. I don't want to show you that. So if you draw it, it will take very long time for you. I'll show you the document. This is what the controller we are going to discuss. This is a very famous LCD controller from Toshiba. See this dot matrix, liquid crystal display controller or driver, both. This is the one which here they mention the displays. See here. 0, 1, 2, every A, B, Q. This is what you are seeing on the LCD display. Using the dots, the number of dots here is like this. Sorry. So this is a chip. See here, you can have a 5x8 or 5x10 dot matrix possible. That means that 5 columns and 10 rows, 8 rows, whatever it is. Okay, so based on that, they are going to have a character or formed. That is called character generator. You need to write all those things. But if you do that, I'm happy. Some of you are doing that. The display, that I'm quite happy. You will understand that. But what this controller did was, okay, see here. For every character, you can form the thing like this. If you make them 1, then that character will be formed. So this is what the controller does. Okay, you see here, that is how that the thing is displayed. Every ASCII value, there is a character. That's called, they call a character generator RAM, whatever it is. And that's we will discuss about that next. So let me get into the board. So what happened was this, like yesterday, what I discussed, LED controller, this LCD controller, that's the beautiful thing. They have a 8-bit to you. They have a 8-bit. And if you give, you know that every character or symbol is having, if we say A means 65, B means 66, 1 means, 0 means 48, 1 means 49. This are all you go and search the ASCII table. If you say A means 96, B means 97. For every character, there's an ASCII value. Now, what they have decided, this is called LCD controller. And this is called LCD display. This is device. Please understand the thing, controller and device. And here is your microcontroller. So I connected one to port. Let us say I'm connected to port F. I'm connected to port F. Port F, I say CHAR star port F or out F. And I say out F is equal to 0x31. Star out F is equal to 65. That will go here. But unfortunately, they said this controller can be configured. The controller can be configured to either make us a 5x6 or clear the display. Okay, or you want to shift the cursor on the right side or left side. and whatever mode you are going to use. Lots of, we'll discuss about that. Lot of modes are there. The controller can be used for various applications, even though one chip, there's a one chip, single chip. You can use it for various mechanisms. I mean, understand. So, am I clear? That is, for various purpose, this controller can be used. For that, they have one more wire called RS. This RS means register set. That what will mean is you are going to use the controller to configure or to send the data to display directly. You can use it for two ways. If you make RS as 0, okay, then that guy will behave like a configure mode. When you make it as a 1, sorry, when you make it a 1, you are configuring. When you make it a 0, that time it will display the character. Let's say, if I send a value 65, you want to display A means this should be 0. Then it will go out to the display. You will say a character display A. So what they did was in the display, this actually the display is 16 by 2. 16 columns, that is 16 characters. And it has 2 rows. That's why we write always 16 by 2. This guy controls all. Each one is a dot matrix. Understand? Each one is a dot matrix. So see, ultimately you're going to give a command and trying to operate that. But still, I'm explaining to you all these things because I want you to know that what exactly is the functionality of the controller. So please understand, one is called device, one is called controller, one is called microcontroller or CPU, whatever it is. The CPU is the one which is going to configure the LCD controller. Then, how this guy will know that you have put the data? When you have put the data, for that, there is a signal called enable. This is called RS. There is a signal called enable. When you make a enable low to high, then that guy will know that you are given the data. This is the way that chip is configured. You can make your own chip, but this chip was deciding like that. Then the controller requires a voltage, 5 volt and ground. And there is one more pin. By giving the voltage here, it's V0. You are controlling the backlight. If you give 5 volt, the backlight will be bright. The LCD will be bright. If you give 4 volt, it will be dim. If you give 3 volts, it will be still dim. You can be able to change the voltage of the controller. It's possible. Understand? So you have 8 wires to tell him what to display. And you have 1 wire for which you are going to control or you are going to display. That is, are you going to communicate to the controller or are you going to communicate to display? That is decided by 1 bit RS. Enable will tell them, hey, I have given data, accept it. So if you make enable high to low to high, a pulse. If you make enable as a pulse, then the controller will accept what you are giving. Otherwise, he will not accept. If you just put the data, it will not accept. Let us assume that. Let us make a program now. If you make that, char star out. If you say out is equal to 0x31, that is this address. Now I say star out is equal to 65. Now 65 comes here, but it's not gone in. For that, you have to make the enabled pin. Let us say that this is another port. This is port F. In port K, I connected here, this one. And I told you I have to make this one as a 0, 2 bits. Let's say this is bit 0, this is bit 1. Now I have to say character star out K. And out K is equal to 0x108. That's a different address because it's a port K address. Then star out K is equal to 0x01. See that I'm making it 1. Say, let us make 0 first. That time that's going to be 0. Then I make star out K is equal to 0x01. I make it 1. Then I make star out K is equal to 0x0. I'm making it 0. I'm pulsing here. This pulse is required by the LCD controller to accept. This is what you don't ask me why. These are all given by the manual. These are all given by the manual. That company, whichever company makes the LCD controller, they're given the information. You have to go and search the net LCD controller data sheet. For example, let us see the thing. Let us see the data sheet. Then you will know that. See here, I have a LCD controller. Okay. This guy mentioned here. See, this is what 16 by 2. And he has given all the display of what is the size and what is the pins, what are the connector, you have to solder everything. And the dot matrix is this much, 5 by 8. See that? 5 by 8. Each dot size, everything has been given to you. So if you see this page, you will understand the display size. These are all there in our data sheets folder in our Google Drive. I've shared all of them. Now, as I told you that, see here, there is a LCD controller. This is your interface. DB0, DB7, and enable. And there's one more thing called read or write. You're going to read the register or write. We are going to discuss about write. That's why I didn't talk about read. Then you see here, brightness control, BO. Then we have the VDD is a voltage, VSS is a ground, and LCD panel. Understand now, this is what it works. And there is a supply to be given to the backlight. Okay, see LED backlight, you have to give a plus and minus. That controls the LED backlight. So this, if you don't give this LED backlight, then that will not do. This is what they're given a pin. Number of pins. See, VSS is a ground. VDD supply pin. V0 is a contrast adjustment. And RS is a register select signal. And RW is a read or write. And E is an enable. Okay, that you should make the signal pulse. And you can, we use it on 8-bit mode, not this one. So let us use DB0, DB7. Then this is what, totally if you see the thing, this display has about 16 signals here, 1 to 16. You see this now? This one.
Sir,
Yeah.
Sir, we have to connect this physically or in simulator, sir?
No, initially you can do simulator, then you should do it on physically. If you successfully do it on simulator, then you can make it on a real hardware. First, you try all the initialization, software, everything on the simulation. Once you have done on simulation, then go to the real hardware. Okay. When you are not done in the simulation itself, then what is the point in wasting your time on the real hardware? There are a lot more variables, connection, everything. Okay, in simulation, you can able to do very well. Now they have discovered what is the current and everything. We don't worry about that. Now you see that. See, the E should be pulse like this. They given what is the time of the pulse width, TW. The TW is what? See here, 300 nanoseconds. It means that if you don't give 300 nanoseconds, minimum, maximum, they don't worry. If you don't give 300 nanoseconds, then that will not write. So you give a data and give the TW. That's what we're going to do now. I'll show you that how I'm doing it. And this is what the display here. They have given all the display character mode. See how each character is formed. T means like this. All once they form T. Or the characters are formed. You can learn it slowly. Yeah, this is what the command. You see here, when RS is 0, you are making command. And the RW is 0, you are writing. 1 means read. Then these are the DB1 to DB9. If you make this bit alone 1, DB0, then it is called DRAM mode. Let's not worry about that. Now let us talk about clear screen. That's clear display. Okay, that is called clear display. And see here, cursor. See here, SC. Set cursor moving. Which direction? Okay. These are all displayed here. So bottom one they have given. They have explained here what is this. See, ID. See, clear display. Clear all the display data by writing 20H. Space mode to all the DRAM address. Or set only this address. If you write everywhere 0, it become clear. That's why it's going. You should do like this. If you write this, so please understand 0001 is a clear display. Then you want to have a cursor off or on. You want to have a cursor on or off. You want to have a cursor to blink. Each bit has to set. See here, shift cursor to left and shift cursor to right, and this one, increment by 1. Okay, shift all displays to left. Cursor moves according to display. Shift all displays to the right, which is all possible. You have to try all of them, all the modes. This is all you have to read and try one by one. Then only you will understand. Whatever I say here are all generally an idea. If you want, you make a sample program and give you. That doesn't matter. But I wish you try it out. That's the way people have to be trying the skill. Okay, so this is what the display. I'll show you now. I'll go to the board and make a connection. Let us make a see here. Let's make a simulator. Let us start from scratch. Let me make this one as a rotation better. So then it'll be easy to access this pin. These pins I want to access. So I make this guy as a yeah, I just rotated it. And I make it smaller size and keep it the side. I can like because I'm not worried about this board. I'm worried about the display. Now I add a display now. I add a display. See, there are so many things. We'll discuss about 16:2. Okay, it is there now. Okay. Now I see here, this guy is having 16 wires, 1 to 16. Now you connect physically. Am I right? Now I connect the same thing here. See that D0 I connected to A0. D1 I connected to A1. It's all port F. Port F I'm connecting now. Learn to connect so nicely, because tomorrow when you see them, it will be very happy. So 8 pins I connected to one port. Now this port, the other port, port K, I'm going to connect. I've already given a document to you. See here, I have shared a document to you for every port, what is address and everything. Every port I've told where it is and what is the address and everything. If it's a port K, the address is 107, 108, and 106. And what are the pins? This I already shared, please. Now I am making the enable pin to 0 bit. And I'm making the read write to ground, because I'm going to write to ground always. So yeah, let me make it from here. From the ground, if I make the wire, that become black. Then register set, I control it to the other pin. Done now. 2 pins. So I've done the connections. Now I have to give the backlight power, anode 5 volts. I give from here. That will be nice. If I start from here, that guy will know that that is red. It's all very easy, man. If you start connecting a breadboard or not, the connection may be there, may not be there. And here, what I'm doing is that power supply, VS. It's a ground. I once again start from ground. And I start the VCC and give it to the VDD. I'm giving a full contrast. So I'm making that also as a V0. So all the 16 pins are connected. Now you see that all the 16 are connected. And let me make it small. Then so here. So if you have any doubt, let me know. I've connected port F to this guy and port do. Is it clear? Now I have to give the commands. So what I've done is, to save the time, I've drawn a picture already with me, which I'll able to. Oh, you want me to zoom in? Okay, I think I've done. I did the. This one is clear. This is what I can zoom maximum. Yeah, this is what the maximum zoom. So we have connected D0 to D7 here, port here, and 2 pins for enable and reset. So register select, and A and K, and ground VCC, and the contrast. I'm giving a full contrast. Now we have to start. This is only a connection. Now we have to make a program. Understand? So we write a program now. I've already written. I'll take that and display it to you. With that, I will share with you also. So that way you'll be able to read that clearly. I'll explain to you this program, the same one. Okay. I'll zoom it now. I'll zoom the program now rather than this one. I will zoom this one. I see code. Now the code is visible. So I have a function called init port. I have a function that means that I want to make all the pins as an output pin. I'm only writing. For example, here I'm making all the pins as output pins. So which I'm going to do that. I'll show you that init port here. I have a init port. This is declaration. You come down and see the init port. I make port F direction 30 and port K direction 107. And I made this one. When you come to this level, when you are discussing with the LCD, you can ask me, I will share the code to you. That's the way people do that. So whenever they come to LCD, they ask the code, I'll share them. Not to everybody, because still a lot of people have yet to start this area. They will get confused. It doesn't useful to them. So whoever requests, I will share the data. It's only on request. Now, see here. So that is why init port. That means that I make all the pins as one, whichever I'm using. FF pins, all the 8 pins on port F. And port K, I use only 2 pins. I make 1. Okay, I'll write the command here. 8 pins. Output. And the bottom one, 2 pins are output. Am I right? Now, that is first. Then I have a thing called out data. We use only one port F to out data. And now, if you call the function out data, if you call with out data, what that guy does, where he is writing, port 31, port F, data is 31, which I have already shown you in the document. See here, port F is port K. You come to port F. Port F, 31 is out. Okay, direction is 30. That is what we have used in the diagram. Okay, this is what out data. Now out control. Next one is out control. There are 2 pins, register select and enable. See here. Out control, port K and 108. And when you give a data, I'll just send it out. That's done. You can write even other way also, fine. This is the way. Now delay. I have a small delay function. After every character, as per timing, we give a small delay. Then we have a write called control write or configure. Using this control write, I am configuring the display. Using the init LCD, I start the LCD with whatever mode I want. That modes, as I told you, the data sheet. The data sheet, I've shown you that there are so many modes. See here. So whether you want to have a display 5x8 or 5x11, or you want to have a 8-bit or 4-bit interface. All those things can be configured by you. Okay, and clear the screen. What is the entry mode? And what is a cursor display? Read all of them. So please understand, this data sheet is the first one you should start learning. How many pages? 22 pages. That's why you have to see first. Oh, how many pages? 22 pages. Even 22 pages, these are all page will go. Am I right? So you actually start from now. Third, for which page? Try to understand all the diagrams, all the pins. You know what that guy is doing. And this is saying the visibility, see, what a viewing angle and everything. These are all very nice. Try to understand them slowly. Don't go away that these are all not my area. If you understand this, you will understand the bigger ones. Suddenly you say that I want to learn only ARM. That is not possible. If you want to learn about all latest controller, you have to understand the EC one. See, I've come to the which page already. See that? 8th page. See, this is what important. Function description. This is the one you have to start learning. Try to understand the line by line this functional description. Then all the registers and everything. How many pages? Done. See, that is only about 4 pages. 13. And go to this page. You start page what? 8. 8 to 14. Only about 6 pages you have done. Now, do this. These are all for hardware people. How this thing, but you can learn it. If you wish, you can do the thing. That's your wish. This, if you see that, you will understand. You can also make a small display using your dot matrix. You can use a dot matrix and do this display actually. That'll be nice. You can make your own LCD controller. Now, what we have done is, we have used these things. I'll show you the code now. Now I'll show you the code, what we have done. In the init LCD. Let us go to the init LCD. See here. Out 38. What is that? 8-bit, 2 row. Am I right? 8-bit, 2 line. How I have come to 38? Why I am writing 38? Now come to the data sheet. This is the way you should go there. Data sheet. And what is the we are writing? 38. Am I right? So here. See here. 0, 0, 0. 0, 0, 0, 1, 1. See this 1, 1. And what is the 8-bit mode? Then dual line. This is 1. N says, see the DL says that it's a 8-bit or 16-bit. The N says 2 line or 1 line. The F says 5 by 11. We make 8. Am I right? That's why we make 0, 0. N is 1 now. Let me put the board, then you will know that. Let me write it on a board. I cannot make board bigger than this. I can write it bigger, but I cannot make the board bigger than this. Now let us say that, see here, you understand here, the first 2 bits are register select and RW. So don't worry about the first 2 bits. Straight from this 2 bit, 0, 0. 0, 0. And next bit is 1. Next bit is 1. 0, 0, 1. DL. Display lines. That is 8-bit or 4-bit. We are using 8-bit mode. So we make that as a 1. The next bit is N. 2 lines. That's why we make it as a 1. And F font. We are making it a 0, 8 by 5. That is what given here. See, I'm not doing anything. Please understand. I'm just following this guy. See here, 5 by 11 means 1. 5 by 8 means 0. That's the convention they follow. The first one is 1, second one is 0. Here also same thing here. See that 2 line means 1, 1 line means 0. And 8-bit means 1, 4-bit means 0. I configure that. All the remaining bits are 0, 0. So what I get now? 0, 0, 1. I got 3, 8. So I've written now 3, 8. So 3, 8 is the first number I want. This is what I've written here. 3, 8. Out data. And I make a LCD control write. What is the LCD control write does? See here. See, I make the bit 1 and 0. Okay. By that way, I could pulse the enable bit. So things are getting written there. That's what LCD control write. Now, then what I do here, 0F. Please understand, I'm outputting 0F. Display on cursor blink. I want the cursor to blinking. How is that? Go to the data sheet. Everything you have to go to the data sheet. See here. You devote first 2 zeros. Next 4 zeros, 0, 0, 0. So 0, 0, 0. Learn to refer the data sheet always. That is what the industry wants. Now you say 1 DCB. What is DCB? Okay, D is called display, C for this one, cursor, and B for blinking. Okay, if you come down, there they will explain to you that what is that. See, display. High means on or off. See, cursor on or off. Cursor blink on or off. So we want display to be on, 1. We want cursor to be on. We want blink to be on. And this is only 1. The data is 0F. That's why we written 0F next. So learn these things by practice. Without you practicing, if you watch the video any number of times, you will not understand. Don't go to the school mode, memorize and warm in. And see here, 01 called clear display, which already I have shown you that. The first one, 01, 00, 001. It's called clear display. Now, next one, I've written one more data, that 06 auto increment. Let us go here. 06, this one. See here, 000, 01, I, D, and SH. Now, what is that? Okay, that's what they have written here. Assign cursor moving direction and blinking of entire display. Okay, now it's written here, bottom, see that. ID, increment or decrement the address. I want the cursor to move right or left. And SH, shift of entire display. You want the entire display to be shifted left or only cursor to move. So right now we want only cursor to move. I don't want the display to move. So that is the reason. And this is called auto increment. If I write one character, the cursor will move to the next character automatically. I do not have to say that, go to next. It will get moved automatically. See that? Address is incremented by 1 automatically. The moment you make the enable line, the pulse. If you display A, for example, if you display A, the thing will go to the next cursor automatically. That is what this. I'm just explaining to you that what is this modes. If you use the Arduino function, you will never know these things. But the industry will expect you to know these things. And it will take only 1 day. Are you going to just saving 1 day? You are going to not understanding this is not right. Only 1 day, man. 22 pages out of it, 8 pages. What is there in 8 pages if you don't understand? You try various modes here, then you will start doing that. You know, this program I'll share with you. You can able to see that one by one. So do you understand now? Now ID is 1. So this is 0, 0, 0. 0, 1. ID is 1. Because I want to increment auto. But I don't want to shift the display. I want 0. So this is going to be 0, 6. Now we have configured the unit port, all of them. 38, 0F, 06, and 01, 06. Now I have a write data. The write data when you give, I write the data, I pulse a pulse. See that, that's what I'm doing here. I'm pulsing the enable. That is what I'm doing here. Understand now. 1, 3, 2. The other one is always 1. That the register select is always 1. Now let us go here. Let us go to the original code, main code. See, only 3 port. I call 3 function. See here, init port. That will make the port as output. Init LCD. It will initiate the LCD. Then I have a write string. What I do here, write string, welcome. Now here, I do in the loop. This is what I ask you to do the C programming. If you're good at C programming pointer, you will understand this. It's quite simple. I till make this is a string. String end with 0. If I change this to anyone, welcome to Isan. First we see welcome. Then we see that here. So now let us make the simulation and run the code. Okay, we make the thing, we make a display only. So it will be visible to you better. Now I run the code. See, welcome. You can see even a dot. If you make it bigger, you will see the dots. See, so many dots are formed using each characters. And cursor I'm blinking. And when I move the cursor, cursor is moving. I'm sending one by one here. You see my code now. If you see the code now, if you see the code now, what the code does? Write string, he is writing data. What data? The pointer. What is the welcome? Now I say, welcome to Ethan. Am I right? Now, if I run the code, see, welcome to Ethan. Now you see, the thing is that if you use the Arduino library or any library, you will get the thing, but it takes how much time? If you sit one day, I'll bet, if you sit one day, morning to evening, you will understand the code thoroughly. There's nothing more than that. I've written only how many lines? 180 lines, and also a lot of space. Am I right? There's a very small code which I already explained to you. Take the video and try to change these things and see that how they are displaying. This is the way the code works. Please understand. This is what the entire concept of embedded controller. First time we are dealing with yesterday's last session 2, we discussed about a sample controller, LED controller that we created. Now this one is a very easy controller to start with, because they're given all the data sheets in a very small one of how many pages? 22 pages. And this is what the display and the controller together. But if you wanted to understand only controller, that is also a 60 pages. Try to understand. See, don't run away. If you, this is what the problem. We always postpone the problem in a small, but when it becomes big, you don't learn it. Better learn at the very young age. That exactly when the problem is small, this is one of the smallest and easiest controller to learn. Understand that. So this is a very famous controller, and this is what we have used the data sheet, what the pin to be used, and we have used this is a company which makes display and controller together. Whereas this guy make only controllers. The Hitachi is a controller only, not display. Whereas this guy is put the controller and display together, sell it to the market. See, controller and panel, both. And you have a common wire, you have a segments. If you go to the controller pins, which I have not displayed but discussed, but it will, if you watch them very clearly, see here, common 1 to 6. Understand, because 2 rows, each row is 8, 8. So 8 into 16. Now you see here, segment 1 to 40, because 2 rows. This is up to 40. This controller can go up to 40 columns, but we are using only 60. Now come here. See the pin. So common 1 to common 16. And you have a segment controls. Segment 1 to segment 10. and the data controls the particular data. What data it is to be displayed on that particular column. On the particular column, what has to be displayed is shown here. So that is the way they make the LCD blinking. They have written a software and it is available internally, or it may be handled by fully hardware. That is their wish. See, this is a ROM, where all your, for every character, what is the dot has to be there is available here. The trick is that you have lost one of the golden days in the college and now try to learn it, but that's the thing. But fine, no problem. Even now, if you take this display, it'll take about 1 or 2 days. But once you understand one LCD, all, see, you wanted to think, what you are trying to do is that trying to master, trying to be a jack of all controllers. But what I'm trying to say is that if you become master of one, then all the others you will understand. All the coming things you will understand without much worry. That's a trick. So let me do the final one. So the thing is like this. Always, this is what the methodology used by the industry. The industry's methodology is very, very simple. There is a CPU. In our case, it's a microprocessor. And we are using microcontroller to control the ports. All are same. CPU, microprocessor, everything. Now, I have a controller. See that I give him only display A. That's all. Whereas this guy displays a A on the display. Whereas this guy is having a memory inside, keep the A here, and he is doing that. Only thing is, what you have to know is not this. This is not required. That is not your area. What, as a programmer, as a embedded system programmer, you should know that what to write, how to write, what to write, how to write. That's it. If you learn this, so first to master the LCD display. I have lots of problems there. I can give you all the problems. If you solve them, then you will understand. But come to this after. See, the problem is without doing the other one, LED, 7-segment, switch, keypad, and dot matrix. Without doing this, don't come here. That is wrong. Finish all of them and come here. Then only you will understand this ones, how they are working controllers. You'll have some idea. You can ask me that, can I do that? Like, no, you can do that. As I told you in the first class, without knowing addition, subtraction, multiplication, division, you can use calculator, nothing wrong. Who is going to stop you? But your growth will not be on this area. You can use the thing for someone else. A lot of people, 90% of people today are doing that without understanding the fundamentals. But I know very clearly, I've seen the industry. If you know with fundamentals, your growth will be like this. Otherwise, your growth will be like this. You'll go like this. Averagely, you'll go like this. This growth will not be there. The exponential growth, if you need long-term exponential growth, better spend your time now and learn the fundamentals. Maybe taking about a few months extra, but you will master that. I'm here to teach you. I'm always there for you to learn it. And don't worry, even if you go to the company, join a company, come to me. Nothing wrong. Okay, then let's take a break for about 5 minutes. And we'll come to the next controller called timer. Let's discuss one or two controllers. Then you'll be having a good clarity of what is that. Okay.